Hello everyone. So in this session we'll see another problem on area by double integration for the Cartesian coordinates. So in this case the question is as such. It says use double integration to determine the area of the region bounded by these two curves. Clearly we can see that these two curves are parabola coming from the parent graph, which is y equal to x square. So let's discuss the curve first. For the first one, which is y equal to 1 minus x square, first of all, the curve has been inversed about the x-axis and then 1 has been added. So it means inverse and then shifted up by 1 unit. Whereas the second one is y equal to x square minus 3. So in comparison to the original graph, this is x square minus 3, which means it has been shifted down by 3 units. So let us see the curve and then the point of intersection, the limits, and then the integration ultimately. So, like I said, y equal to 1 minus x square. The inverted graph about the x-axis shifted up by 1 unit. The second one is y equal to x square minus 3, which is shifted down by 3 units from the parent graph, which is x square. So, instead of x square, we have x square minus 3 like this. Now, for the intersection part here, we need to find some points, this one and this one. So this can be done by solving both the equations. So both the y's will be equal in this case, and the values which we can find here coming from y1 equal to y2, let's say. So 1 minus x square equal to x square minus 3. That is 1 plus 3 equal to 2x square. So 4 equal to 2x square, or x square equal to 2, or x equal to plus and minus root 2. So it's clear from here that this point is actually x equal to minus root 2, and this one is actually x equal to root 2. The region enclosed is this one, and if you talk about again taking the vertical strip, like dividing the region here, so let's say we are taking something like this here. Clearly we can see that the initial point, let's say P, lies on the curve which is y equal to x square minus 3, and the end point, let's say Q, lies on the curve which is downward, and that is y equal to 1 minus x square. The limits for x will be from minus root 2 to root 2. So in this case we can say that the limits we have got is x varies from minus root 2 to root 2, y varies from P to Q. So P is x square minus 3 to 1 minus x square. Q is 1 minus x square, lying on the curve 1 minus x square. Now the area required will be integration x minus root 2 to root 2 y x square minus 3 and 1 minus x square dy dx. So first integration in terms of y, putting the limits, whatever result comes, integration in terms of x, putting the limits again to get the final value. Okay, so first integration dy, that will be y. So y with the limits x square minus 3 and 1 minus x square, whatever we get here needs to be integrated in terms of x with the limits x equal to minus root 2 to root 2. So this is 1 minus x square minus x square minus 3, whole thing integrated with respect to x. So this one, 1 minus of minus 3 becomes 4, minus x square and minus x square becomes minus 2x square, and the limits. So this is 4x minus 2x cubed by 3 minus root 2 and root 2. So this is the upper limit, 4 root 2 minus root 2 cube will be 2 root 2, so that is 2 times of 2 root 2 minus 4 root 2 by 3 minus 4 times of minus root 2, so minus 4 root 2, and that will be minus of minus, so plus 4 root 2 by 3. So this is 8 root 2 by 3 minus, this is minus of 8 root 2 by 3, together minus of minus become plus, so this is 16 root 2 by 3. This is the area we are looking for here. So again, following the same steps, we have got the result for the area of the region enclosed, 16 root 2 by 3. I hope this is clear. Thank you.